Welcome to A-Level and EP Physics. In today's lesson, we will discuss past paper questions from June 2023 Paper 4 Variant 2. In today's lesson, we will talk about quantum physics, nuclear physics and X-rays. As always we will discuss these questions in detail so you can improve your conceptual understanding of these topics and also you can have better understanding of these questions. Let's study together, let's improve together. Question 8 says figure 8.1 shows the lowest 4 energy levels of an electron in an isolated atom. Figure 8.2 shows the lines in the emission spectrum of the atom that corresponds to the transition of electron from N3 to N1 and from N4 to N1. So we need to find out which line belongs to N3 to N1 and which line belongs to N4 to N1. But for this question it is given to us that frequency is increasing this way, to the right frequency is increasing, and energy of photon, emitted photon, this is equal to h time f. So if frequency is greater, it means energy is greater, so we can also use arrows here. So it means this line has higher energy, this line has low energy, this line has high energy because it is due to photon of high energy, and this line is due to photon of lower energy. Now let's try to understand this one with the help of energy gap. First of all, electron jump from N4 to N1, so we can use orange line for that, and then electron jumps from N3 to N1, so we can use red line for that. Energy gap for orange is greater. So first of all, let's try to understand the main concept. Delta E is greater if energy gap is greater. So simply we can say energy gap, or you can say the gap between lines. Energy gap, or we can say gap between lines. If the gap between lines are, you can say energy levels. If this one is greater, it means that delta E is greater. As this gap is greater for N4 to N1, it means that N4 to N1 has higher energy. So it means this line is the orange one, and this line has to be the red one. So this is for N3 to 1, and this one is for N4 to 1. So these are the points you need to understand to answer next question. I hope these points are clear to you. Part A says explain with reference to photons why there is a single frequency of electromagnetic radiation that corresponds to each of these transitions. Imagine that there is one single electron in this energy level, and this electron jumps from N3 to N1, means to the lowest energy level. As this electron jumps from this energy level to this energy level, and this is just single jump, one jump, so it means this is one transition. So we can say this one is one transition. So this is single transition, and in this single transition one photon will be emitted only. So this is our photon. So we can say single photon, or you can say one photon will be emitted. And the energy of this photon, delta E, this energy is equal to energy difference between these two energy levels. So this is certain amount of energy, or we can say this is fixed amount of energy. So you can say certain, or you can say this is fixed amount of energy. Energy of photon, this is equal to hf. F is frequency of EM radiation. Frequency of EM radiation. So if we have energy of the photon, we can figure out type of EM radiation that photon belongs to. So this is meaning of frequency of EM radiation. For example, if this frequency is equal to frequency of visible light, or it is equal to frequency of UV light, it means this emitted photon, this belongs to UV light. This belongs to radio, it belongs to gamma. So we can figure out by calculating frequency. So this is the frequency of EM radiation. So these are the points you need to understand. As you can see here, energy of photon is fixed. So it means this frequency is also fixed, or we can say this frequency is single frequency. So every time electron jump from here to here, it will emit EM radiation of single frequency. Now let me show you how you can write down the answer for this question. In order to write the answer for this question, you have to include these points in your answer. The first one, you can say transition emits one photon, as we have discussed here, one transition, one photon, with energy equal to the difference in energy between the energy levels, means between two levels. We have discussed delta E. This is certain amount of energy, or we can say this is fixed amount of energy, because the energy difference between two energy levels is fixed. And frequency of emitted radiation, this corresponds to the energy of photon emitted photon. As this energy is fixed, this frequency is also fixed, so this is single frequency. So this is how you need to answer, and this question has 2 marks. If you have written these 2 points, you will get 2. Part B1 says, on figure 8.2, draw a line that corresponds to the transition of the electron from N2 to N1. Label this line A. For the second part on figure 8.2, we also need to draw a line that corresponds to the transition of the electron from N3 to N2, and we need to label that line B. We have discussed already the main concept, how to draw these lines. So let me redraw again one. So this line we have discussed, this is for N4 to N1, and the next line, this is for N3 to N1. So we can draw this orange line. So this is for N3 to N1. And also we need to remember that the gap between these energy levels is almost the same as the gap between these lines. Now for this question, we need to draw for N2 to N1. So we can draw this green line here. So this is 1.6 centimeters, 1.7 centimeters. This is 1.7 centimeters. We can draw line from N3 to N2 as well. So this is N3 to N1. So this is 2.4. So we have 1.7, we have 2.4. So it means 0.7. So we can draw line from here, 0.7. So this is 1, so we can make it bit smaller. So this is 0.8, so this is 0.7. Now simply we need to draw a line here. So we can draw one blue line here. So this is 1.7. So we can draw it. So this is for N2 to N1. We don't need this arrow, so we can clean that part. And for the second part, N3 to N2 means N3 to N2. We need to draw the line for this part, and this is about 0.6. We have to compare this one with N2 to N1. N2 to N1. We have already discussed that this is equal to 1.7 centimeters. So let me write down proper. This one is 1.7 centimeters. And this one is 0.6. Let me recheck this one. This is 0.7. 0.6. So this is 0.6. So we can write here, this is about 0.6 centimeters. So what is the difference between these two? That is equal to 1.1 centimeters. So we can draw the line here. From here, 1.1 centimeters. So we have 1.1 centimeters. So we can draw the line here. Let's use different color. For this one, let's say this color we use. So we need to draw a line here. We don't need this arrow, so we can delete this one. So this is N3 to 2. So this is how you need to draw in a beautiful way. You can use your meter rule, you can measure the distance, and you can draw these lines. When you draw these lines, you have to be careful with the gap. Means the gap between these two lines, means this gap has to be greater than as compared with the gap between these two lines. So you can see it is very clear. This is about 0.8, this is 0.8, and this one is more than that, so this is 1.1. so this gap is very important. You have to take care of this one. And you can also see here, you can also compare the gap here. So these gaps are almost the same, and when you will use meter rule, maybe you will not get these values of the gap. Your values will be different because I'm using this paper, and this paper has different scale as given in the original exam, but ratio will be the same. Means this gap will be smaller as compared with this gap. So if you measure with meter rule and you draw the line, your ratios will be the same, but you will not get these values. Ratio will be the same because these two different papers, the paper I'm using, this has different scale as compared with the original scale. If you're using A4 size paper, when you print, also size will be different, but ratio will be the same. So this gap will be smaller as compared with this gap, and this is also required. If this is not correct, you will lose marks. So this gap has to be greater. Part C says the frequency of radiation represented by line A is F sub A. The frequency of radiation represented by line B is F sub B. The energy of the ground state is E1. Determine an expression in terms of Fa, Fb, E1 and the Planck's constant for the energy E3 of the energy level n equal to 3. So for this one, it is given to us the energy of the ground state is E1. And when we move from N1 to N2, energy is increasing. And energy increased by HFA. So the energy at this point we can write on E2. E2 has to be equal to E1 plus HFA. And then when electron move from N2 to N3, the energy gained by the electron, that energy is HFP. So at this point, E3 we can say this will be equal to E2 plus HFP. So simply we can say in this case E3 has to be equal to E1 plus HFA plus HFB. That's all what you need to write on. So simply you can write on here E1 plus HF sub A plus HF sub B. And this question has 2 marks. The first mark you will get if you have written E is equal to F. So you will get 1 mark, and this one is the C mark. And you will get 2 marks if you have got the right answer. Question 9 part A says define mass defect. Mass defect we can also call mass deficit. So if you see this term mass deficit, or if you see terms mass difference, it means we are talking about the same quantity, mass difference. So we are talking about the same quantity. Let's try to understand this one with one simple example. Imagine that we are talking about helium nucleus. Helium nucleus has 2 protons and it has 2 neutrons. So we have 2 neutrons, we have 2 protons. And if we draw the helium nucleus, inside helium nucleus we have 2 protons here. So these are 2 protons, and we have 2 neutrons. Imagine that total mass of these nucleons, let's say this is equal to capital M. So we are talking about the total mass of these nucleons, and the mass of nucleus, let's say this is M. Mass defect simply means delta M. This will be equal to capital M minus small m, means the total mass of the nucleons minus mass of nucleus. So this is what you need to understand to answer this question. So let me show you the answer, how you can write down your proper answer. In order to write down this answer, you need to write down difference between mass of nucleus and total mass of nucleons when infinitely separated, means they are far away from each other. So if you write on these 2 points, you will get 2 marks. First mark is M mark, the second mark is A mark. Means you have to mention infinitely separated. Part B says table 9.1 shows the mass defects of 3 nuclei. The nuclear fusion process in a particular star is given by this equation, where X is a particle that has no mass defect. So this is very important point. For part B1, we need to state the name of particle X. So simply we need to balance this equation. So we have atomic number 2 here, and also we have 2 on the left side. So it means this one has to be 0. Atomic number has to be 0. It means this particle has no charge. and the mass number of this one has to be 1. So it simply means that this particle is neutron. It has no charge and its mass number is 1. So this is neutron. And this question has only 1 mark and this is B mark. Second part says show that the energy released when one nucleus of helium is formed in this fusion reaction is equal to this one. But if you look at given data, for this question we have mass defect. This is not mass of nuclei. So the mass defect for the product, it has to be greater than the mass defect for these reactants. So we will take the mass of this one, mass defect for this one, and we will subtract the sum of the mass defects of these two hydrogen isotope. So this point is important one. We need to calculate energy release. So delta E is equal to delta M times C square. So we can calculate delta M first of all. So let me calculate delta M. Delta M mass defect will be equal to the mass defect for helium nucleus. We have this is 0.030377 minus mass defect for hydrogen isotopes. We have 0.002388 plus for the second isotope we have 0.009105. So this is in U. So if we solve this one, we will get 0.018884. This is in U. So we can convert this one into kgs by simply multiplying with 1.66 times 10 to minus 7 kgs. Because 1 U, this is equal to 1.66 times 10 to minus 7, 27 kgs. Now we need to calculate delta E. Delta E is equal to delta M times C square. So we have value of delta M, that is equal to 0.01884 multiplied by 1.66 times 10 to minus 27. So this is the mass defect. We will multiply this one with 3.00 times 10 to 8 square of this quantity, and if we solve this one, we will get 2.8 times 10 to minus 12 joules. So this is how you need to calculate. If for this question what is given to us, this is mass defect, and this is neutron, this is loose particle, it has no mass defect. And this question has 3 marks. The first mark, if you have written this formula, you will get 1 C mark, and the second mark you will get if you have calculated value of delta M, means the net mass defect, and the final mark is for the answer. If you got the right answer, you will get 3 marks. Part C says the star in B has a radius of 2.3 times 10 to 9 meters and luminosity of 1.4 times 10 to 28 watts. All the energy released from the formation of helium atoms is radiated away from the star. All the energy that is radiated from the star has been released in the formation of helium atoms. Determine the mass of helium atoms produced per unit time by the fusion process. So we have power of the star, so simply we can say power of the star, this will be equal to number of atoms produced per unit time, time energy of energy released in single reaction. So for this question we have power and also we have energy released in one nuclear fusion reaction. So we can say N over delta T, this is equal to P over E. Power we have, that is 1.4 times 10 to 28 watts, and we have energy released in one nuclear reaction, that is equal to 2.8 times 10 to minus 12. So if we solve this one, we can find out number of atoms produced per second. We will get 5.0 times 10 to 39. So these are the number of helium atoms produced per second, but we need to calculate the mass produced per unit time. We can calculate mass produced per unit time, so simply we can write down mass per unit time. Mass per unit time, this is what we need to calculate. Now we have number of atoms, so we can write down number of atoms, 5.0 times 10 to 39. So we have number of atoms, and mass of one atom, mass of one atom is equal to 4U. This will be equal to 4U because its mass number is 4. So 4U means 4 times 1.66 times 10 to minus 27 kgs. Now simply we need to multiply with this one. So this is mass of one single atom. Mass of one single atom. So if we multiply this one, our final answer in this case will be equal to 3.3 times 10 to 13 kgs per second. So this one is the final answer. So this is how we can figure out. This question has 3 marks. The first mark you will get if you have got right number of atoms produced per second, and the second mark you will get if you have written the mass of single helium atom, and the third one you will get if you have got the right answer. So this is how 3 marks will be awarded to you. For the second part, we need to calculate the surface temperature of the star. So it simply means that we have to use Stefan-Boltzmann law. Stefan-Boltzmann law simply tells us the power radiated by a star is equal to surface area of the star 4 pi r square times Stefan-Boltzmann constant time temperature to the power of 4, T to the power of 4. We need to calculate temperature in this case, so simply we can write down here T will be equal to L divided by 4 pi r square times Boltzmann constant, and the power of this one is 1 by 4. Now simply we need to plug in values. We have value of luminosity that was equal to 1.4 times 10 to 28 divided by 4 pi. Radius of the star is given to us in the question, that is equal to 2.3 times 10 to 9 square, and Stefan-Boltzmann constant is 5.67 times 10 to minus 8. Now if we take power of this one 1 by 4 and we solve, our final answer up to 2SF has to be equal to 7800 Kelvin. So this is surface temperature of the star. So this is how you can calculate. This question has 2 marks. The first mark you will get if you have plug in these values. If you have written in this form, you will get 1 C mark, and if you have got the right answer, you will get 2 marks. Question 10 part A says X-rays for use in medical diagnosis are produced in an X-ray tube. In the X-ray tube, charged particles are accelerated towards a metal target by an applied PD, potential difference. State the name of the charged particles that are accelerated by the applied PD. So in production of X-rays, first of all, we heat up metal. We produce electrons by thermionic emission. Means when we heat up a metal, electrons are emitted. That process we call is thermionic emission. So this is how we produce these charged particles, and these charged particles are electrons. For the second part, we need to explain how X-rays are produced at the metal target. So when accelerated electrons, they hit the metal target, means they hit the anode, they decelerate, and when they decelerate, they lose kinetic energy, and the loss of kinetic energy is converted into X-ray photons, or we can say the loss in kinetic energy is emitted in form of X-ray photons. So we can write down, first of all, we have accelerated electrons. So we can write down in steps. Accelerated charged particles, or simply you can say we have accelerated electrons. They collide with matter target. Collide with matter target, or you can say collision with metal target. So they decelerate. Lose Ke, so they lose Ke, and X-ray photons are produced. So X-ray photons are produced. So these points you have to write down in your answer. So let me show you the answer, or you can write down your answer. In your answer, you have to mention these points. You can say electrons are decelerated on impact with the target, matter target. Loss in Ke of electrons emitted as X-ray photon. As X-ray photons, and this question has 2 marks. These are 2 B marks. If you have written, you will get 2 marks. Pretty straightforward one. You need to understand how X-rays are produced. Third part says calculate the minimum wavelength of X-ray photons produced when the applied PD is 5.80 kilovolts. Minimum wavelength. So minimum wavelength simply means that if all electrical energy has been converted into X-ray photon energy. So this is first thing you need to understand. All electrical energy has been converted into X-rays photon energy, means electron just simply stop. So all the kinetic energy has been converted into X-ray photon energy. That lambda we need to calculate. So simply we need to equate two energies. So we can say in this case electrical energy, that is equal to Q times delta V. This has to be equal to the energy of single photon. We need to calculate wavelength, so simply we can say Hc over lambda min, minimum wavelength. Lambda min we need to calculate, so we can say lambda min, this one has to be equal to Hc divided by Q times delta V. H is a Planck's constant and the value of Planck's constant is 6.63 times 10 to minus 34. Then C is also constant, its value is 3.00 times 10 to 8 divided by Q. Q is the charge on single electron, 1.60 times 10 to minus 19 coulombs, and potential difference is 5.80 times 10 to 3 volts. Now if we simplify this one, we will get our final answer 2.14 times 10 to minus 10. So this is X-ray photon. So you can see the power is minus 10. So this is in range of X-rays. And this question has 3 marks. The first mark you will get if you have written this formula, you will get 1 mark. Then the second mark you will get if you have plugged in these values. Then the third mark is the answer mark. If you got right answer, you will get 3 marks. Part B says X-rays pass through a medium that has an attenuation coefficient of 1.4 per centimeter. Calculate the percentage of the X-ray energy that is absorbed by 2.8 centimeters thickness of this medium. First of all, we can simply imagine this one is our medium and incident intensity is I naught and transmitted intensity is I t, and the thickness of this medium we can also say this one is x. So value of x is here, we have x is equal to this one and this is value of mu. Now simply we have to use it, this is equal to I naught e to the power of negative mu x. So we can find it over I naught. So this is the transmitted intensity, the fraction of incident intensity. This has been transmitted, so we can calculate this one, e to the power of mu. Mu is equal to 1.4 and x is equal to 2.8, and if we solve this one we will get 0.0198. so this is it over I naught, but we need to calculate percentage absorb. So percentage absorb we have to calculate, how much has been absorbed, that one we have to calculate. So we have this is the transmitted and rest has been absorbed, so we can simply take, in this case we have 1.00 mean this is the incident minus transmitted is 0.0198. we need to convert this one into percentage, so we have to multiply by 100, and so this fraction is transmitted. So how much has been absorbed, that is 1 minus this fraction. So that's the reason we have written 1 minus this fraction of incident intensity that has been transmitted. Now if we multiply this one with 100, we will get this is 98%. So this one is our final answer. And this question has 3 marks. First mark you will get if you have written this formula, you will get 1 mark, and the second mark you will get if you have got this value it over I naught, and the final mark is answer mark. If you got the right answer, you will get 3 marks. That's all for this video. I hope this video was helpful. If these videos are helpful, please like and subscribe because your encouragement is very important. And also if you need extra help and you wanna support this work what I'm doing on YouTube, please join Patreon, and link for Patreon you can find in the description of this video. See you in next video, and if you have any questions, please leave your questions in comments.